Hello everyone, in this video we are going to derive a relation for one-dimension steady-state heat conduction through hollow sphere by using a spherical coordinates. By using heat conduction equation of spherical coordinate. Now this is the heat conduction equation of a spherical coordinate for a unidirectional flow, steady-state heat conduction and without heat generation. So from this relation we are going to transfer 1 by r square to this side. So we are reducing this relation to this, that is d by dr into bracket r square dt by dr is equal to 0. So this relation we are going to have a second order derivative. So we are going to integrate the equation number 1 twice. So integrating equation 1, what do we have? Integrate equation 1, we get, so with respect to what we are going to integrate it? With respect to r. So equation 1, integration of equation 1. So first integration will deduct this d by dr. So we have only r square dt by dr is equal to c1. So I will mark this equation. I will first of all transfer this r square to this side, so that dt by dr is equal to c1 upon r square. I will mark this equation to be as a second equation. So dt by dr equal to c1 upon r square is my second equation, and it is also a slope. Okay. Now further I will integrate it again. Integrate equation 2, we get with respect to what? Again with respect to r. So integration of dt by dr, it will become t will be equal to integration of c1 upon r square, it will be equal to minus c1 upon r plus c2. So this will be the third equation. Integration of 1 by r square is nothing but a 1 minus 1 by r. Okay. So after getting this, what is your next step is to find out a boundary condition. Okay. Now let us see what are the boundary conditions. So consider a sphere having inner radius to be r1, outer radius to be r2. It has a thermal conductivity, the material is having a thermal conductivity of K. The inner surface temperature as T1, outer surface temperature as T2, and we are going to assume T1 is greater than T2. Okay. Now the previous equations were dt by dr equal to c1 by r square. This was the second equation, and the third equation was t equal to minus c1 upon r plus c2. This was the third equation. Let me check. Yes, it was the third equation. Now the boundary conditions will be, boundary conditions are, in this case, at r equal to r1, what are the temperature value? T equal to T1. Okay. Second boundary condition, at r equal to r2, T equal to T2. So you need to put this boundary condition in equation number 3. So putting boundary conditions in equation 3, we have, what do we have? So at r equal to r1, t equal to t1, what will be equation number 3? Equation 3 will be t1 equal to, yes, minus c1 divided by r1 plus c2. This will be your equation number 4. At r equal to r2, t equal to t2. So your equation number 3 will become t2 equal to minus c1 divided by r2 plus c2. Now we are going to subtract equation number 5 from equation number 4 to get the value of c1 first. subtract equation 5 from equation 4, we have, what do we have? T1 minus T2 will be equal to C1 by R1 plus C2 minus C1 by R2 plus C2. ठीक है, so taking negative side inside, what do we have? Minus C1 divided by R1 plus C2 minus will become plus C1 divided by R2 minus C2. So this plus and this will get cancelled, remaining will be T1 minus T2. Okay, so here from this side we are going to take C1 common, so it will become 1 upon R2 minus 1 upon R1. Here we are going to have T1 minus T2. Therefore C1 will be equal to T1 minus T2 divided by 1 upon R2 minus 1 upon R1. Okay? Now we need to put the value of C1 in either of the equation, either equation 4 or equation 5. So putting value of C1 in equation 4, we have T1 equal to minus C1 divided by R1 plus C2. ये इक्वेशन है, इसमें हम C1 का वैल्यू पुट कर रहे हैं, तो minus 1 upon R1 it will become T1 minus T2 divided by 1 upon R2 minus 1 upon R1. C1 का वैल्यू हमने पुट किया है equal to C2, so T1. So transferring this term to this side, therefore C2 equal to T1, this minus will get plus, so plus 1 by R in bracket T1 minus T2 divided by 1 by R2 minus 1 by R1. So this will be the value of C2. So I will mark this to be as a 6th and this to be as a 7th. Okay. Now getting the value of C1 and C2, what we are going to do? We are going to put the value of C1 and C2. Put value of C1 and C2 in equation 3. टेम्परेचर प्रोफाइल का इक्वेशन है, क्या इक्वेशन है? T इक्वल टू माइनस C1 अपॉन R प्लस C2. ठीक है, सो व्हाट विल बिकम टेम्परेचर प्रोफाइल इक्वेशन विल बिकम T विल बी इक्वल टू माइनस 1 अपॉन R T1 माइनस T2 डिवाइड बाय 1 अपॉन R2 माइनस R1 प्लस C2 का वैल्यू, C2 का वैल्यू क्या है? T1 प्लस 1 बाय R T1 माइनस T2 डिवाइड बाय 1 बाय R2 माइनस 1 बाय R1. Further you can reduce by taking this and this common. What you are going to have? 1 minus T1. So T1 minus 1. So either you can take it common or you can keep as it is. So this is the temperature profile in a case of a sphere. ठीक है, टेम्परेचर डिस्ट्रीब्यूशन और टेम्परेचर प्रोफाइल इन अ केस ऑफ अ स्फीयर. नाउ लेट अस अप्लाई द फूरियर लॉ. अप्लाइंग फूरियर लॉ, व्हाट डू वी हैव? Q equal to minus KA dt by dr, but dt by dr is here. Now what is your dt by dr? Dt by dr is C1 by R1. So it will become C1 by R1. ठीक है, not C1 by R1, it will become C1 by R square. Sorry, dt by dr is C1 by R square. So it is C1 by R square. ठीक है, so Q will be equal to KA C1 by R square. Now put the value of C1. We have What is the value of C1? Let us check. C1 equal to T1 minus T2 divided by 1 by R2 minus 1 by R1. 1 by R2 minus, yes. So Q will be equal to Ka T1 minus T2 divided by 1 by R2 minus 1 by R1. ठीक है. Also R square 1 by R square. ठीक है. Now putting the value of A is 4 pi R square. So Q will become K 4 pi R square into T1 minus T2 divided by 1 by R2 by R1 divided by 1 by R square. R square and R square will get cancelled. So what you are going to have, minus 4 pi K T1 minus T2 in the denominator will become R1 minus R2 divided by R1 R2. Okay, so Q will be equal to 4 pi R1 R2 K T1 minus T2 divided by R1 minus R2. This multiplied by minus. Now here you can see in the denominator it is R1 minus R2. So inner radius minus outer radius, it will always give a negative sign. So what we are going to transfer, this negative sign we are going to take in the denominator instead of numerator. So you have 4 pi R1 R2 K T1 minus T2 divided by R2 minus R1. So this is the same relation which we have derived by applying of application of a Fourier law, in a topic of application of a Fourier law. But here we have found out this relation with the help of a spherical coordinate. Okay? Thank you for watching this video.